Before we get into the show, I wanted to put out a hiring call. I'm looking for my next software engineering apprentice, a young .NET programmer to help me directly with my work, building architectural prototypes, figuring out new patterns, tons of coding. And I'm looking for a .NET programmer whose hobby is also programming. For the right person, programming isn't work, it's play. And besides a job, I can guarantee that you will learn faster than you ever have before. And I will invest in your professional education and we'll work together and you will grow. You'll report directly to me. So if any of this sounds interesting to you, just send me an email or give me a call. Now, let's get into our show. The latest in C# with Mads Torgersen.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software consulting firm delivering mission-critical software projects, as well as acting as third-party project inspectors. And you can find them on clearmeasure.com. And we are in, quick announcement, the second year of my architect forums. Signups at the next session are up. And if you lead a software team, if you're looking to collaborate with other peers like yourself, then this is the forum. We understand there's plenty of educational material for developers out there on the web, but not so much for people who are leading teams of developers. So that's what this is for. It's free. It's a group of peers all sharpening each other. So you can sign up at the link in the show notes. And for those of you who are looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories. You'll be able to find it. And today on the show, we have a returning guest, Mads Torgersen. Mads is the lead designer of the C# language and has been at Microsoft for over 18 years. And prior to that, he was a professor and contributed to a language starting with the letter J, perhaps. And he was previously on episode 164. He was talking to us about C# a couple of years ago, and we have him back on the show. Welcome, Mads, back to the Azure DevOps Podcast. How are you, sir?
I'm doing great. Thanks so much for having me back. I guess it wasn't a complete disaster last time.
No. Awesome. I appreciate it. The C# language keeps on trucking on, and you are, you're the leader of the language. But for people who didn't see the last episode, or haven't kind of followed you, although you were at the .NET Conf, you gave a presentation there, and you gave a lot of presentations. Can you maybe back us up and share your journey and the high points along the way that led to you kind of being the chief of the language that so many people use?
Yeah, I think if one word sums it up, it would be serendipity.
Yeah.
But yeah, I thought my path was going to be as a researcher. I got myself a PhD. I was, assistant and then associate professor for a number of years, always focused on programming language and type systems and stuff like that. And during that time, I got deeply involved with the Java generics effort, which was going on at the same time as the .NET generics effort back a couple of decades ago. And I just had so much fun having an impact on a real language that when I met Anders Heilsberg at a conference where we were both talking about, the generics that we were working at, it made sense for me to make a jump to industry. And I moved to the US and started as a PM on the C# team, got to be, part of the language design process alongside Anders Heilsberg for a long time. And then at some point, we were finally rolling up our sleeves and being like, okay, the C# compiler should be in C#. We started the Roslyn project and completely re-implemented the C# compiler from scratch. And essentially, Anders and I got the message that, could you just hold off on crazy language design for a second while we just catch up to what's already there? And so we were kind of loose cannons there for a bit. And we went and did TypeScript with a bunch of people on the JavaScript team. And when that turned out the way it did, which is to say pretty good, Andrews decided to stay there. And then all of a sudden, there's a chance for me to step up and be the lead designer of C# after him.
Nice. And he's still pushing TypeScript forward?
Oh, yeah. He's still going strong. He's doing amazing stuff.
Fantastic. Now, that's interesting, the C# compiler moving to C#. Now, was it C++ or was it ANSI C prior to that?
It was C++ before.
Okay. In .NET land, we're nice and sitting happy and fat working on C# with our garbage collection and all this stuff, but there's just tons of C and C++ code, still being written fresh out there that .NET developers just kind of happily ignore.
Yeah. I mean, there are still reasons to pick one of those languages. I'm not going to engage in any language bashing here, but there's certainly a lot that you don't have to worry about when you're on a garbage collected platform, that's for sure.
Absolutely. Well, I know that people who are paying close attention saw you at the .NET Conf this past November, and you gave some sessions there and some announcements. But would you mind just maybe catching us up? If there's plenty of developers that are maybe they haven't seen the latest, but maybe catch us up over the last 6 months, and what are the high points that people need to pay attention to with where the C# language has gone?
Well, in terms of where it already is, in terms of shipping releases, like the one we shipped in November, C# 12, alongside .NET 8. Hopefully you can keep adding 4, subtracting 4, and it'll stay at the same distance from now on.
Right.
I mean, there are always a number of big and small features. I think, well, there were kind of two that were highly impacting, I think, in that they could really change what your code looks like for the better. One is collection expressions, which is a syntax for, creating a new collection by listing out its elements between square brackets. That's really all it is. There's there's a syntax for spreading in all other collections as well, but that's pretty much it. It might not seem like much, or is it just a new syntax? But the fact of the matter is, all our different kinds of collections didn't have a unified way of getting created before. There were just all kinds of different syntaxes depending on whether you were creating an array, a list maybe, an immutable thing in which case you ran out of good syntaxes and had to reach for bad ones. And then some of the syntaxes were kind of like a pit of failure from a performance perspective. If you did the obvious thing, you would be wasting cycles or allocations or something like that. And so by adding a unified syntax for this, we are really solving that problem well and good, right? You can essentially, you don't have to worry about how your collection gets created. We have, you take this collection expression and you assign it to a target type or pass it to some target type. And we have all kinds of ways in the compiler of figuring out how to create it and good heuristics for how to do it the most as efficiently as we can. So we really aim for this not just to be, it's a great simplification of your code and it's a bunch of stuff you don't have to worry about, but also you can trust that the compiler is doing its best. And its best is probably better than yours, unless you really bend over backwards, in which case you have bend over backwards code that you need to maintain, right, in terms of performance. And if you run into a case where, hey, doesn't look like the compiler is doing as well as I could here, well, you'll tell us about it. In the next release, we can improve the implementation, right? So we got this pinch point of abstraction that we can improve on release over release. So that's really a key one. And it's one that we'll keep leaning into for, a release or two. We'll probably keep optimizing it forever whenever we find new ways of doing that. But we'll also expand the reach of it in terms of scenarios it applies on. So to kind of talk about C# 13 a little ahead of myself here, we're thinking about a syntax for it that works with dictionaries, essentially a dictionary expression variant of it. So you can also get your maps of various kinds. So that was one big feature, and it's been super well received. And for the cases that it doesn't yet address, we do also get feedback why doesn't it do this? And we're we'll thank you. Thanks for the scenario. We'll think about it. We'll try to work that one out as well. So that's one. And then the other one that's pretty visible, I think, is what we call primary constructors, where for the many cases where you have trivial constructors in your ordinary classes and structs, you can just put instead of having that specific, explicit constructor in your body, you can just put constructor parameters directly on your class. You can even pass them to your base class as constructor arguments, and then they're just in scope throughout the class. You can use them to initialize your fields and properties, or you can even bypass that and use capture on them, which means that if you just refer to the parameters directly from within like a method body or a property body or something, they will just get squirreled away in the object for you by the compiler, and they'll stick around for the lifetime of the object. So it's just it's a very nice convenience. There are some corner cases that it doesn't deal with yet, and so again, it's a potential candidate for refinement in the future. But that's kind of like that's our thing now that we're on a yearly cadence, that we like when we have a good feature, we don't let the perfect be the enemy of the good. We try to think ahead to see if we release this part of it now, are we at risk of going down a dead end, like blocking ourselves off from something great in the future? And so we try to design ahead enough to kind of test that out. But if we're confident enough that this is a benign subset of the feature, we're gonna roll it out, and it's not going to do everything, but it may do the 80% scenario. And then there might be a bunch of 10% scenarios that are difficult for us to choose from. Like, what should we do next? Is it worth it doing anything else? But by rolling out that 80% scenario, we'll get user signal on it, right? And so we can just iterate with the users on a yearly cadence and say, wow, that was the thing that people were really running into all the time. Now we have our priorities, but now let's go and address that one first.
Sure. The default constructors is a really fascinating feature, and I intuitively know that it's just better than the way I've been doing C#, for 20 plus years. But you mentioned it squirrels it away. And when I was learning the language, I would do the IL disassembly. I'm like, okay, what's it actually doing here? And so for being in scope for the whole class, what is it actually doing? Is it just another private field? Is it a net new type of member? Like, what is it actually at runtime, those default constructor parameters?
That's a really good question. If you don't refer to them outside of construction time, then they're nothing. Then they just go away, just like your constructor parameters. If you do capture them, as is a term we use, that is, you use them from a member that can get called after the object is constructed, then they become a private field with an unspeakable name, like with a name that you can't use from within the language.
Okay.
So it's like there's so many other things that we do like that it's just a compiler-generated field that only the compiler can generate the code to access.
Gotcha.
So it's not that you get a private field that you can then say, this dot, my field. It's hidden. If you want a field, then declare a field and just initialize it from the primary constructor parameter. It's more like if you have lambdas or local functions, you can also talk about the local sudden parameters from outside of it. That's also a kind of capture. And then we'll do the same kind of thing. We will make a little object, or sometimes it's a struct for performance reasons, that contains it as a field, but you won't be able to get at that field directly. It's just an implementation strategy.
Okay. If I have code that references it in a method, then I'll get one of those kind of hidden private fields and it'll keep it around in scope. But if it's only for initialization, then that memory that's not even kept around. It's like dynamic compiling depending on what I'm doing.
Right. We don't want a situation where you end up having two fields for the same thing.
Yeah.
And there are a few ways you could get yourself into that. And we do catch those and give you a warning about it. Let's say that you capture one of these primary constructor parameters, but you also pass it to a base class. Now, the base class is probably going to squirrel it away somewhere as well. So that's one where we'll give you a warning and say, hey, it's not a good idea to capture this because you're probably storing it again, and your base class already did. If you really mean to do that, then explicitly do it with a field. So we try to make sure that capture doesn't lead to double storage.
Now, are all of these as Roslyn analyzers? Is that the warning? Is that the mechanism these days for all of them?
I think those are built into the language. I think we just built those warnings into the language.
Gotcha.
In the user experience, that boundary is is rarely really observable. I guess you can see if the error code starts with CS, then it comes from the compiler.
Mm-hmm.
But I mean, part of the analyzer idea is that's kind of that's a porous boundary. Like you should get, when you have an analyzer, the experience you get should be as close as possible to if you have a built-in warning.
Mm-hmm.
So it doesn't matter so much. Sometimes when there are things that we think are people would commonly want to have warnings about, and that they are more expensive to implement from the outside, quote unquote, we'll just build them into the compiler, and maybe even in certain cases turned off by default. But then an analyzer can just turn them on.
Right. Well, there's some of these new features where I think it's still too early to see how it's generally going to impact or how much it's generally going to impact. It's more of okay, maybe we have hypotheses about that. But some of the features in a couple of releases prior, my question is, do you have any idea about how it's actually impacting people? For example, the non-nullable conversion a couple versions back, where the first time that I upgraded a code base and I say, you know what, I'm gonna go to the new non-nullable, and I had to go through all the different things that I had to change and the different properties that I had to add the question mark, because you know what, I need this one to be nullable. No, let me just leave it as null. Have you been able to observe generally how it's changed what is kind of normal, quote unquote, C# programming because of that?
Yeah, I think that is one. That one is special, I want to say, because that really was like it was a mode change, right? You have to have a flag on to even get it, and then it kind of gives you warnings you didn't have before, so it was kind of breaking, right? It's rare that we do. We're looking at maybe getting into a few more breaking changes in the future, but that's its own story. But it does mean that if you already have a large code base, you may not want to go, if it's kind of well tested, you don't suspect it, and it may not be very alive anymore, right? It might just be sitting there, and you're only sort of doing maintenance on it.
Mm-hmm.
It might not be worth it to go through the effort to kind of get the compiler in agreement with you that we don't see any null issues here, and so but when you start a new project and you kind of get those warnings in real time, then it's really helpful, right? It helps you. Oh yeah, I should remember the question mark here, or hey, yeah, this doesn't actually. Oh, I should make this member required. Right, required properties really patched a hole in the nullable story there. So it does seem to kind of split to some degree on whether people are working on existing code bases or not. Like because there's not a big like upfront cost if you're in a new project to kind of enter.
Right.
It also influenced our design back then, honestly, to make it so that you could incrementally adopt it. You don't have to have null checking on everywhere. There are various ways that you can have it only in some projects, or even only in some parts of your project. You can turn it on and off on a line-by-line basis even. As a compiler director really made sure that you could sort of, even if so it might not just be that you want to leave some code alone forever. It might also be that, well, I turned it on, I'm getting 1,000 warnings. I want to do this, but I want to do it little by little. I want to start by having my public surface area that I'm sharing with others be well annotated, so they get a better experience, so they get the right kind of nullability things from my API. Well, I can start with that, and I can start with even parts of it and gradually work my way to where I feel, okay, this is good enough. Maybe you only ever you can even split, right, between whether you what you expose, the annotations you expose, versus the checking that you do internally in a body. You can do that. You can set the flag separately for those if you really want. So we gave you all these knobs so that you weren't stuck with a million warnings. You could kind of gradually chew your way there if you wanted to, or you could choose just not to.
Yeah.
On existing.
With the latest features, it was too early to know. Actually, have any of the internal code moved to default constructors in a way that you're able to see the actual impact on a reasonably sized code base, or is it still too early even for some of the Microsoft teams to report what they found?
I don't think there's that much, and I think that goes to there's probably some, because the tooling can tell you whether it's a safe thing to do, and you can just go and use the refactoring in VS that does it when it is. But again, generally speaking, there's a little hesitancy about going back and changing existing code. Right? There's been some of it. And for collection expressions, I think there's been quite a lot of it. Because like while the primary constructors is primarily a convenience, like it's a nicer syntax, but you fall off the cliff and can't use it anymore. You have to use the full syntax, and the full syntax can express everything. Collection expressions do actually give you benefits, right? Because of this, of the compiler's investment in giving you the most optimal kind of translation of the expression. If you go and use them, you're essentially subscribing to future compiler improvements in the space, as opposed to trying to manually keep remembering to do the best thing, and even when the best thing, whatever the best thing is, changes version over version. So there you really kind of get a benefit, a long-term benefit from switching to it. And I do see that quite a lot. People do clean up their code with collection expressions quite a lot. Nice.
I remember so much here. I remember when .NET first came out, because we're in the gray hair club, but and everybody was going to.
I thought this was audio only.
And everybody was kind of learning what this .NET thing is, and so there was lots of texts and books and conversations about what things were going on under the hood and internals, and so we learned and kind of studied how the language did things, and we looked at kind of what the IL looked like, and we learned the language features. For new developers coming in now, in your view, what is the best way for them to actually learn the language and what it's actually doing? Because there's a whole the internet searches are all full of this history of changes and code examples of all different variations. But if someone's just coming in fresh and they want to actually learn the C sharp and the current, what is, in your opinion, the best avenue?
Well, that's actually that's a general problem that we have in old languages, right? The internet is trailing. Like the bulk of stuff of C# examples on the internet are outdated, right? Or they will work, but they will not be the best answer, right? And so there are a couple of things. We're trying to, from a docs perspective, many of you probably know Bill Wagner. Maybe you've even had him on your show. Otherwise, you should. He's over in docs doing a great job of kind of pulling the newest best practices to the foreground. So if you're kind of coming in through that, through the samples there, you'll kind of be more and more hitting the best stuff first, like the right stuff first. We've been talking about this concept of everyday C#. Like what is the subset of a now large language like C# that really is your everyday toolbox? And that is a moving target, right? Every time we add a new feature, or most times when we add a new feature, it's because it does something better than what was there before, in our opinion, right? We're trying to do something better than it was. And so all else equal, it should replace the old thing in the everyday C# toolbox. And kind of structuring our docs around it, maybe trying to unify a little on what we mean by everyday C#, kind of suggesting to third-party authors and so on. And also making sure in our tooling that we kind of help pull you forward. Like oftentimes when there's a new language feature, there'll be a little suggestion ellipsis showing up in Visual Studio, for instance, to say, hey, you could use pattern matching here. Want to try? And then you'll be like, oh, pattern matching. Let me see what that looks like. Oh, that is really cool. I don't understand this, but let me click and go to documentation or, let me play with it here. But having these things that pull you forward and tell you, like, here's what is now a better way of doing what you're already doing. I think, could we lean even more into that in the future? Probably. But it's a path that we've started down on more deliberately now. And I think we can keep fleshing that out as we get experience with it.
Yeah, and that's really strong in Visual Studio. I haven't checked VS Code to see what the parity is on those suggestions.
Well, it's much better than it used to be.
Still working on it.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Well, going forward with C# 13, I guess is the one that's aiming for .NET 9. And of course, anybody can go onto GitHub and see, the I guess the comments on the issues or whatnot. But you guys have so many conversations internally as well. How would you enumerate your goals, regardless of what you decide to do with a particular feature? What's the goal? What are you attempting to accomplish this year with the next version of C#?
Oh, so at a high level, without going into features, I think every release of C#, we try to have a balanced mix of things. We try to have a few things that help what you could call productivity scenarios. Just code got easier, nicer, cleaner, simpler, more beautiful, more expressive. Then there'll be things that are aimed at performance. So we have sort of, it used to be that the underbelly of C# was unsafe code, and now we have safe replacements for most of what you used to have to do in unsafe code that involve spans and ref structs and all kinds of things that I would say are not part of most people's everyday C#, but that allow the subset of C# developers that build really performance critical frameworks and infrastructure and so on to kind of get all the way to the performance you would expect from C or C++ or something. And there's usually like a next step in that journey as well. And this is no exception. Sometimes we also try to fundamentally expand the set of abstractions available to you. And I know that's that's a very abstract term to use, but really like the core fundamental abstraction mechanisms in C# and .NET, you should say they are what they are, but there are ways that we can evolve those as well. And not every release, but frequently we do something that push the boundaries in that as well. Didn't do so much of that in C# 12, but we have things in C# 13 that are aimed at trying to get you new abstraction mechanisms to help you better with kind of layering and separation of concerns and so on, and you sort of coding at large, if you will.
Yeah, the structure, like where to put code, how to organize code.
Yeah, essentially how to, we're sort of, the way we're thinking of it is that we're taking good old extension methods and we're turbocharging that feature in several directions, allowing you to essentially add any kind of member to any kind of type after the fact, or nearly any kind of member, which helps people layer their code and lower the number of dependencies or the trade-offs between unhealthy dependencies and a good user experience. If you can make a member show up on dot in more places, then without actually that member being part of that type, well, then you just enable some more separation. So it's almost like at a software engineering macro level. I think this is going to really help. But when we do though, and then last time we did like an an abstraction mechanism feature like that was when we did static virtuals and interfaces, which allowed us to finally have interfaces that have operators as members that you implement, right? So every time we do that kind of thing, it's more of a slow trickle where people need to pick up the use of that abstraction mechanism and then start to benefit from having used it and so on. So those are like more, they're sort of like on a several year horizon of rollout in a different way than just a new nifty syntax.
Well, that is big.
But it's important to do some of those once in a while, right? Otherwise you're just like polishing everywhere and not really making a difference.
Well, I do remember, it's old news now, but before the services collection advent, before dependency injection was kind of embedded into .NET as a normal thing to do, you had plenty of people that was just, okay, a project references a project references a project, and now you have IntelliSense because you have access to it. And then there was just this pocket of developers like, no, we're going to use a dependency injection pattern and we're going to figure out how to do it. And now it's just normal because it was kind of baked in to how you do the language and the base class library combination. So that has a profound effect on how people arrange their code now.
Right. That's exactly the kind of effect I'm talking about, right? Where it just, assuming it's successful, which of course, if we didn't believe it would be, we wouldn't be doing it. The impact isn't going to necessarily show itself in large numbers within the first year of release, maybe, but it'll start to trickle that as more and more people discover the things they can do, it'll change to some degree how they shape their code.
Yeah. Now, before you joined Microsoft, you were a professor and you're in the education space and researching, and computer science curriculum talks about the different types of languages and like 4GL languages, and then this concept of 5GL, and just like this hierarchy. And I know that's a little bit of theory and philosophy kind of baked into it, but in your mind, where does C# fit? Does it have a clear category, or over time, is it gonna move? And is there a goal to have it be a higher category of language? How do you think about that whole space and the theory behind it?
Oh, that's a really good question, because we do, in fact, think about it quite a bit. I think it's fair to say that C# started out squarely in, I don't know if we use like generation on numbers, who can keep track of that anyway, but squarely in the camp of imperative object-oriented programming language with garbage collection, right? That was sort of like where we started. And everything was structured around what object-oriented programming state of the art was at the time, essentially. So it was very kind of clean in terms of its category. Then over there were functional programming languages and also at the time not necessarily super popular, but also very sort of clean family of languages, if you will, that in many ways was complementary to object-oriented programming, and they had kind of different or many times even opposite solutions to almost any problem. And so it felt like a really like fateful decision. Should I go into this type of language or that type of language? But in terms of like level of abstraction and like there were probably like nuanced differences in the scenarios you'd use them for and so on, but it wasn't that one was inherently a higher level language than the other. They were simply just rallying around different core abstractions. And there were some early examples of people trying to bridge the gap, so to speak. And I want to call out Scala here as probably the first language with a decent amount of popularity that really tried to say, well, let's try to unify these seemingly opposite concepts, and they did a really good job at that. And I think as a kind of like model for that, they've been on my mind a lot, because it turns out functional programming does have answers to a lot of problems that object-oriented programming doesn't solve as well, and vice versa. So what we've sort of done from the early outset, even from C#2 and certainly C#3 with LINQ and lambdas and all that stuff, is to try to take the functional concepts that really solve a problem better and find a way to integrate them as deeply as possible into C#, so they don't feel like foreign elements or imports from another world, but that they kind of mesh in. That's kind of been a maneuver that we've tried repeatedly, at least a dozen times, I would say, with different like functional based language features, and certainly many other features as well from that we've seen elsewhere. Sometimes we had to come up with our own to solve a new thing. And what that means is that while C# remains an object-oriented language at core, it's sort of addressed in what I would say elegant ways many of the deficiencies that object-oriented programming had. And that's been really fortunate as we move to the cloud, for instance. There are just many things that functional paradigms are better for when you're in a cloud scenario, and we've really diligently adopted and merged those into C# in a way that should feel like home still. And we'll probably keep on doing that, honestly, harvesting other paradigms and other languages for great ideas, as many of them do with us as well. And what you see now, I think C# is not alone in this. And what you see is that most of modern popular programming languages do have some kind of hybridness to them. They have a core identity, and then they pretty elegantly embrace other things as well. Can you go full functional in C# and do functional programming as elegantly as an F# and as kind of natively? No. And you probably never will. If you want the full functional experience, you go to F# and you get you really get it, and that's awesome. And then all of a sudden you're like, here and there you're grasping for objects, and you find that they, just like we adopted functional concepts, they embrace object-oriented concepts on the side as well. But I think it's a general trend. We're trying to be pragmatic. We want elegant, beautiful, coherent programming languages, but we also want them to solve everyday problems, because at the end of the day, that's why people use them. You don't want to use the language just because it's beautiful. You want to use it because you can solve your day job with beautiful code in those languages.
Yeah. Correct me if I'm wrong, but I remember in the late 90s being educated on the generations of languages, at the time. Is that kind of like an old, outdated classification, even, as the modern languages are just able to take certain elements of others and be a cross-category creation?
I don't know. I never, honestly, if you quiz me on it, I can't even remember which generation does what. The numbering of generations felt like a bit of a marketing trick to me. It's like, we are like mammals to dinosaurs here. They're sort of trying to say, we are in a completely different, sphere now. It's nothing is as you're used to, and so on. And that was I think that was just a bit of a gimmick, to be honest. Not trying to make light of your education at the time. So on the one hand, yes, but on the other, there are paradigms there. The fact that we mix and match in the actual languages doesn't mean that the paradigms aren't still there. So in that sense, it does make sense. You just can't neatly sort the languages into cleanly belonging into their own category anymore. And the desire to do so seems to be all but gone. Like, people really don't care that their language, fits a certain categorical label. They care that their language caters to their users and maybe attracts new users as effectively and elegantly as possible.
Sure. Now, there's some public talk, which I want to get your take on it, regarding the generative AI and creation of code, and then I've encountered at least one university student who is backing away from computer science because the fear that somebody told him that, oh, you don't want to go into programming because that's going to get replaced with generative AI, and you are in the language business. And so if there's just machines that are kind of generating, language instead of people, well, that directly affects your business. So what's your take on if any categories of code is actually feasible to be replaced by, the generative large language models, and which type of code just inherently is incompatible with being able to, be generated versus a software engineer actually deciding how to craft the C#?
Well, I think of the impact that generative AI is having and will have even more so as in the coming years on development as primarily a productivity boost.
Mm-hmm.
That's how I think of it. I mean, you kind of have to separate between people using AI in their apps, which is another thing, and then there's AI playing a part in, writing the code or whatever they do. Maybe they don't even write code. Maybe they just stick around and do the thing. That's terrifying. But what I'm seeing so far is that it's better at some things than others. And if you use AI in sort of like a collaborative manner, you use it as sometimes you use it almost for sparring. It's like, hey, what would it look like if let's try to scaffold out if we try to follow this architecture and solve this problem. And I don't remember this algorithm. What where you have some sort of like an interplay, like a co-pilot like experience of that, essentially like just turbocharging what a tool like Visual Studio already does, which is try to anticipate what you would like to do next.
Mm-hmm.
Like it's a intelligence on steroids, and also make your next steps as pleasant and as productive and as efficient or quick to do for you, while still keeping you in control and still having you able to feel confident that the end product is right.
Mm-hmm.
And there may be some areas that are fully automatable, but I just don't see that nearly as much as people fear, at least yet. I see it much more as a, hey, I just became, I talk to more and more people who are like, I'm so much more productive now.
Mm-hmm.
It's both that I can write code quicker, but actually also with higher quality, which is, you kind of think is surprising given all this talk about hallucinations. But it's it's reminding me of things I hadn't thought of, right?
Mm-hmm.
That would have been my next bug. So that's that's more the kind of impact that, at least for the foreseeable future, that I'm seeing. Just as again, I'm not speaking for Microsoft's AI
Sure.
efforts or anything like that, but just the way I see it, it's just gonna be, with quotation marks maybe around, just gonna be another productivity booster for developing code.
Mm-hmm. You mentioned hallucinations. The risk is much greater when you're doing, say, legal research than when you're asking for the generation of a little bit of code that, by the way, a compiler is just going to see if it can compile seconds later, versus you maybe including some research in a legal brief and it being flat out wrong. So I think, and it's great to have your take on it, if it ever does happen where we can now, I guess, move up another level of abstraction and just present an idea to the machine, and it kind of does it properly, as opposed to write the code to tell it the right sequence to do it, then it seems to me that would be a new type of source code in and of itself, where whatever level of instruction I'm commanding the computer, isn't that the level of language that I would want to store in Git? As opposed to having it generate some C#, and then I, as the human, am on the hook for now maintaining forevermore some C# that was generated anyway.
I do see what you say. And your guess is as good as mine here.
Yeah.
And I may be old-fashioned. As you mentioned, we're part of the gray hair club.
Yep.
I can't count the number of times that programming as we know it is over.
Yes. In the 90s, there was a wave there.
Somehow, we're still writing source code.
Yeah.
And somehow that still seems to be the best medium for communicating between humans and computers, and over time for evolution of software and so on. It just seems irreplaceable. Even these it's going to be graphics now, or it's going to be natural language or whatever. It just keeps on not happening.
Right.
So there's something about source code that is incredibly sticky through half a century now, or more, that I want to see it before I believe it. And so far, that is not what I'm seeing with the AI. Let me just put it like that. It can be a help in many ways, and it can certainly also, AI as part of functionality that you build into your apps, that's big as well, right? That is definitely an enormous new front. But it's still not replacing source code. It's still not that you can just put your prompt in GitHub. And
it's not deterministic.
The rest kind of just takes care of itself. I just don't see it. It's to me, that's another red herring. But, by the time I'm proven wrong, well, maybe I'm retired or something. It won't matter.
Well, I like to ask this question to different people, given how everybody's talking about, the GPT era of AI, and just to get everyone's take. And I haven't encountered anyone yet who is able to say and back it up. Oh yeah, the number of programmers out there in the wild is going to start decreasing on this date, and this is why. When really, I think all the trends, all the data that I've seen has it not just increasing linearly, but continuing to, have a slight exponential. It keeps increasing at a faster rate. The need for people building software and writing code, and there's something sticky about it, because in the late 90s there was these case tools that were going to generate entire applications just by describing what they needed to do, and those are gone. Nobody.
Yeah, somehow they didn't stick around as much.
Right.
I think we should definitely acknowledge that a disruptive technology like this, even if the fear of jobs going away might be overblown in a kind of global sense, it definitely definitely rocks the boat, right? And and maybe not so much for us developers, even though I might be wrong about that, but in a broader sense in society, there'll be people who will struggle because of AI, coming for their jobs in some sense, right? Or a big part of their jobs, where the productivity that it lends will lead to smaller teams instead of better product or something. We'll absolutely see that, and so I don't want to deny that or belittle that. I think that is all societal change has some of that. If every such paradigm change had led to new levels of mass unemployment, well, wouldn't we be seeing quite a lot of unemployment now, right? At the macro level, I think society fills in and generally tends to use the productivity boost to kind of get to a next level. Let's just hope that it's a environmentally sustainable next level this time.
Right. Well, it seems to me that this type of technology is kind of akin to transportation. It used to be that few people had, the early cars and automobiles. They were expensive, and the newer technology didn't decrease the need for transportation. It just made it where more people had access to it. And same thing here. Software is expensive. The programmers, you gotta learn. You got to spend a lot of time learning just to get into the game. And then companies that hire developers, software is expensive, but if we're more productive and things are at a higher abstraction level, then I could see more people being able to program certain types of applications without having as much schooling. Kind of like websites. 20 years ago, you had to know a certain big amount of stuff just to put a website on the internet. And now it's like click, click, click on Squarespace or Wix or something, and you're done.
Yeah. I mean, productivity boosts are productivity boosts, right?
Yeah.
regardless of what technology enables them.
Well, hey, thanks for that little detour, but getting you
It's always
back in
fun.
your professor roots and a little bit of philosophy. So I appreciate it. But is GitHub still the best place for people who've kind of never seen the open source side of C# to just jump straight into the GitHub repository?
Well, when you ask the question like that is the C# Lang repository is where all the artifacts related to C#'s design reside, right? So that's where you go to look at the latest design notes and all the proposals and all that stuff, all the discussion there. But it's a very noisy, busy place. So it's kind of a high barrier to entry that way. It can be difficult, but hopefully not impossible to kind of just nip in and take a look and hop back out. Sometimes there's a lot of context where docs are sort of your next level down for like something that's more curated and will give you more of an overview of what's going on. But
Awesome.
what generally tends to happen nowadays is that whenever a C# feature goes in preview, then there's also a preview doc for it in our docs, right? So you can go and see what's new in C# 13, and that's currently empty. But as soon as things start trickling out in a way that you can try them at home, just by using the preview flag to the latest C# compiler, then there will also be docs, and that can be a way to kind of keep up. That is more, that takes a little less of your precious time.
Yeah, awesome. Well, hey, I appreciate you coming back on the show and sharing with us the latest in C# and the philosophy behind it. It's always fascinating. Thanks so much for coming back.
Thanks for having me. It's been an absolute pleasure.
Oh, my pleasure indeed. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.